Welcome back again, everyone. So today I'm going to be taking apart this Fisher and Paykel dishwasher. This is one of those like dual drawer dishwashers that has like the drawer on top. And it was supposed to have another drawer down here, but I already took that apart. Basically, the two things are, or the two drawers are pretty much exactly the same. And the bottom one, whoever had removed this from the house had already kind of taken it off the rails and everything, so it was already out. I have a little pile of parts from it like sitting right here, so that's what I'm doing, basically just kind of parting it out, keeping some of the stuff, building up my inventory of junk, much to my wife's dismay. But whatever. So anyways, yeah, like I mentioned, both drawers are pretty much exactly the same. It's got some buttons up here. It's got a couple of little capacitive buttons right here that let you select whatever like wash mode you want. Okay, first of all, this was a curbside pickup that I saw, and this got some interesting stuff, and that's the only reason I kind of want to take a few parts out of it. You can see that whoever removed this already kind of had a crack at some stuff right here. It's got these little pins that were supposed to be like here on the sides to hold the drawer to the rail. Apparently this is like the bottom sprayer arm thingy, whatever it's called. So yeah, down here this is basically like a little brushless DC motor, and this is what pumps the water around into the sprayer unit here, I guess. Yeah, this looks like it just sits on top like that. Huh, that's interesting. I thought it would have been like clipped down or something, but I guess it doesn't. So yeah, anyways, this just fits on there. This thing like pumps one way to spray water out, and then when it wants to drain the water, it spins in the opposite direction. And we'll see that when we remove the motor here, but it's got this little thing here that will open up. That brings out this whole sort of a stainless steel strainer. It's got this other little strainer down here too. Check that aside. And right here it's got this other piece that should open up, and that's where the motor actually is. Well, actually that's just the magnets, the rotor. So we can see down there the impeller for the pump to pump the water out. So that right there would be just the magnets. So the coils are down here. So I have to remove the drawer. And as I mentioned, this one's already gone. The other one is still right here, so I'll remove that. But once I do that, I should be able to pull this drawer out. Okay, both sides of that are off, and this is starting to come off right here. Oh, it's completely falling. Okay, so that's, yeah, it's kind of just like this front, the plate. Just it's got some foam in here for like sound dampening and insulation, because you don't want the tub getting like all cool or anything. And inside we can already see some stuff. So this right here is a little 24-volt blower. Got a few little things here, little actuators for the soap dispenser and the rinse aid. Right here is the control board that goes to pretty much everything. You can kind of tell that they expect these things to leak over time or whatever, because this right here with this foam brick is basically a float switch. So if there's too much water accumulating down here, this little float here will start floating and trip a switch that's in there, and basically, you know, alert the main board that it's filling up with too much water down here on the bottom. So, and you can see that there definitely was a lot of water accumulation down here. There's a lot of rust. A few other things that we can see back here, all these lines that run from the drawer to the rest of the cabinet, they go through the sort of like a cable guide, so that when the drawer opens up, it can pop out like this, and when you push it back in, everything can kind of tuck back inside. Down here on the bottom we have down here, these would be the fill valves, and because there's two drawers, it has two fill valves. That line that we see coming right there, that would be like the hot water coming in. There is a switch down here that you can see that's mounted on this rail, so that when you open the drawer, the switch can detect that, you know, the drawer is open. When you close it, you know, it'll trip the switch or whatever. There's only one. The other side doesn't have one. They just sort of have like this spring-loaded latch to kind of like hold the drawer shut. Another interesting thing back here that I'm pretty sure is this is appears to be a vacuum pump. This is actually wrong, but continue watching because we'll figure out why further along in the video. It's a really tiny thing, and I think there's going to be two of them, one for each drawer, because what it appears happens is that when the drawer is closed, there's a seal up here. It pumps the air out of the drawer and makes a seal against this gasket, so that water, you know, should not be like spraying out. outside of the drawer, because I mean you really have like nothing else to hold the water in once the drawer is closed, and because the water's spraying upwards, you know, it could easily just kind of come out and drain out and come out the bottom like so. And then it looks like right up there at the top, that looks like it might be a pressure relief valve, and we see a bunch of other lines going up here that would be going up to the second drawer. And these white tubes right here, those are the fill tubes for each drawer. You can see how it's hooked up into the dispenser, so the hot water would come into here, and that's where the hot water kind of goes out into the rest of the drawer. The drain line goes to the bottom of that brushless DC motor that acts as a pump as well. So we'll see that once we get to it. This, I believe, should just pop out. So this is it's like a duct, like to blow air down the bottom. That would just be like venting the air out through here. There is a big heatsink in here in the power supply. You can tell that some components on here have gotten pretty toasty because this plastic is all discolored. Looks like this machine was built in October 14th of 1999, or at least this particular module was. Looks like this vent also might suck air, or the fan, you know, like kind of sucks some air from inside of here. There's a little vent right there, and there's also a vent in the back, and I think this may be like an inlet, so when it's drying the dishes, you know, it's got somewhere to pull air in from. Okay, so this piece is out of the bottom. It just had some clips up here in the front and right there. That was kind of like underneath these connectors. And so now we can kind of see the underside right there. That's where the motor is. You see some tubing and a lot of lines coming in this way. Apparently I can't remove the entire drawer just yet, so I gotta undo some of these lines that go to the back like they do on that one. Then I should be able to pull the drawer completely off, and we can flip it upside down and stuff. So what we'll need to unplug here is this one here that says line mains, which is this first connector. That comes off, and then the flood switch, the fill valve, the lid pump, and the exhaust valve. And then we need to pull off the fill hose. Okay, we'll squeeze that, pull it off. Now this should pull off. Okay, there we go. And this has a clip, I think, on both sides. Okay, so that's that. Should come off, pop out. Yep, still got some water in there. Cable guide just needs to pop out of here. We can see it's got these sort of like hinges right there. So pop those out somehow. Okay, there we go. So that's out. Now I can pull the drawer off. And sure enough, there's another one of those pumps. And here's one of the drawer slides. These feel pretty heavy duty, but I mean, they kind of would have to be, because once this thing's like fully loaded, you know, it might get pretty heavy with dishes. And here's the other side. This is the one with the switch. You can see how when you close the drawer, this pin that's on the top section of the slide there kind of goes into that groove, pushes all the way back, and the spring action kind of pulls it so that it can shut all the way, just like that. And it activates that micro switch right there. So the pump and the little relief valve seem to be on this sort of a flexible mount. It's inside of a groove here. I don't know if this is just gonna pop up. Oh yeah, I just push up on it. There is a little wire right here. Oh, that just pulled out. So that's the whole valve and pump assembly. And it looks like it's just a solenoid in there. I don't know if it's got like a plunger that's moving back and forth or whatever, or if it's got something that's spinning. We can take this apart and kind of look inside there and see how it actually works. And these cable guides, they just have these sort of flaps that open here. They're just kind of clipped on the side. So once that opens up, all this wire and the tubing should be able to come out. One thing I think is kind of funny is how there's two strands on each side of 22 gauge for the AC coming in. So one would be for the live and the other side would be for the neutral. And that's all that's supplying power to everything in each drawer. So this is the top drawer one, and then this is the bottom drawer, and yeah, same thing, just two thin strands of wire. Here in the back is a panel that looks like it'll give us access to the AC inlet and stuff, and I mean it would also give us access to the valves and things. So there's a screw there. Probably have to use both hands here because looks like I need to pry up on this and push up at the same time. Okay, yeah, that was a trick. You have to use two hands. So then this comes out, and there is the AC inlet box right here. A piece of paper covering it. Oh wow, there's actually some filtering and stuff in there. Didn't expect to see that. I thought it was just going to be like the AC going straight into these lines that I was talking about. But these also have a couple of connectors, as we can see on there. I guess I would have known what was in there if I had seen this label right here in the back. But all that's out now. Okay, and that's all the electrical and electronic stuff out of this cabinet. This dishwasher has become nothing but a shell of its former self. Okay, and for the drawer, we've got these tabs here. Looks like we just pull up on these, and that releases the control panel, I guess. Yeah, there it goes, and there's a connector right here. We'll unplug that. Let's unplug the drying fan, let's unplug the hall sensor, let's unplug the motor. Okay. And down here on the bottom, we only have one more. This one says the element, so that would be the heating element, and that allows the entire control module to come apart. So that's that. And that's that heatsink I was talking about. You can tell by how discolored this thing is that it gets pretty toasty, and especially if this is if it was made around '99, it's like 20-year-old dishwasher. Holy crap! Yep. And here in the top, these are the capacitive buttons that we saw up there on the top, and then these are the LEDs, and these are bicolor LEDs, so they change colors depending on what you select. And then there's two modes. It has like the I guess like the energy saver mode, and it's got like the regular mode, so they light up like green and red. In the meantime, let's finish removing all this other stuff off of here. So we got the fan, and it just came apart. These come apart though, it just has a couple clips on here on the side. And there's the LED right there for the rinse aid dispenser. So what I don't know exactly how this works, but I think what it does is it lights up, and if you can see it on the other side, I think you might be able to see it through here. Like if there's enough rinse aid, I think you would be able to see the light, and if there's not, then you can't really see it, because the rinse aid would be acting kind of like as a sort of like a light pipe. I think that's how that works. I'm not entirely sure. So there's a few screws holding this whole assembly in place. The only thing that's left down here is the motor and the heating element. That's that thing right there. That's this big plate. Okay, so that's this thing out. There's a hole where this LED fits into. And the only thing left to remove is the motor assembly. And there's this tab right here that kind of holds it in place. So if we move this to the side, and then rotate this entire plastic ring on here. Oh, that hurt. Okay, but it's loose now. Okay, now this thing should just pop out. And there it goes. Okay, this thing here also comes off. Oh, never mind. It comes out the top, so just gotta undo these wires from this little guide here, and this comes off. And then this can come off. And that's the heating element. You can see how it's all kind of like printed on this plate. It's these two right here for the heating element, and it's got these other two right here that go to this little tiny diode looking thing right there, and it says U351. That's going to be a temperature sensor. And these two yellow gaskets here, one goes around the heating element right there to seal the plate to the bottom of the tub, so I'd be in there. And then this other ring, goes right here, and that's what seals the motor assembly to this plate. And these gaskets they're hollow. They're just kind of like, they're tubular. Tubular. And this is the motor assembly. So it's pretty hefty. It's got quite a lot of iron in here, and it's got these pretty large windings. It's got 6 of them. And we can see how we have the A, B, and C lines running in through here. So we got the 1, 2, and then 3. And then there's the other side. That's all the commons tied together. Yeah, I believe that's a Y configuration. If I'm wrong, somebody let me know. So, and then this little board right here is I believe this is a hall sensor. And this little tab here pushes out, and the board can be removed. and that would just be basically for like positioning the or rotor positioning. So it would be like 5 volts ground, and then or probably 5 volts ground, and then one of these would be the output. And if we look down there in the bottom, we see there's 2 holes or 2 ports. So one would be the inlet and the other one would be the outlet. And this is the outlet right here, so the right side is the outlet. So this rotor, it has this sort of a ring right here that's kind of like a bearing, basically like a sleeve bearing to support the rotor shaft down at the bottom. That has to fit in these grooves that we see inside of here. So put this in, kind of like, gotta get these to line up. There you go. So now once they're lined up, the whole assembly just sort of drops down, and then this thing locks into place by turning. And that's the pump motor. And here is that flood switch. It has 2 switches in this assembly, and it looks like this lever here pushes on both at the same time. So it's fairly easy to push on that lever, and I mean, you'd want it to be, because this floater is like really light, although it's going to put quite a bit of pressure once there's enough water in there to push it up. So that's where the lever here kind of sits. So it sits something like that. And if you look at it from the side, you can kind of see how that, well, that sort of like mesa right there just kind of pushes up on that lever. So let's open this up. We're going to see 2 micro switches, and we can kind of see maybe how like this is attached to both there. So it's got these tabs that looks like they just pop out. Okay, there we go. It's all, well, okay. This one's out now. There we go. So there's the 2 switches, and it kind of popped out. So here's the switch partially reassembled, so we can see how it works. That lever down there has a tiny spring that kind of holds it over to this side here, so it's activating this switch. But the way they're wired is that one of these is using like the normally closed and the common pins on the micro switch, and the other side is using the normally open and the common. When the flood switch isn't activated, this side here would be closed between this point and this point, and that's how it is right now, as we can see. And then this side, because it's not being activated, it's using the common, and it would be using the normally closed position, which would be this one right here. And if we look at the wear marks on the connector there, I didn't see which one was which, but yeah, we can actually see that the wear marks are on this contact here, and this contact in the center doesn't have anything on it. So when the flood switch gets activated and the lever closes, then it switches to where the contacts on this side here are now open, and on this side here it opens up the contact. So now it's open between this point and the common. So they just have them connected in opposites, but they're basically doing the same exact function, in that when the flood switch gets activated, the contacts open on both sides. Okay, I'm not going to bother opening this up for the time being. There's something I want to try, and I'm just going to leave it closed. But I can show you what's inside, because as I mentioned, I already have the other one. This machine had a bad lower drawer, and I think it was because the pump on the bottom drawer was actually seized when I first got this thing. But anyways, because this seized, I think that something must have shorted on here, because when you apply power to it, you just hear the kind of like a whining sound coming from the power supply, and like nothing else happens. So yeah, I had already taken this apart, and inside we just have that heatsink there that goes to this power device here, and that's for the switching of the mains transformer right there. It has quite a few power rails. There is like a 40 volt rail, a 24 volt rail, and a 12 volt rail. So the 40 volts is for powering the power section of the motor driver. So that would be this right here. So these are basically like totem pole drivers right here. So one side would be the positive side, the other side would be the lower side. And all these are being controlled by this microcontroller in this section. And the only way you can tell that is because if you like trace these out, you can kind of see that they go down here too. All these like smaller driver transistors that are in here in each section. So there's 2 microcontrollers on this thing. There's the one right there, and then there's the second one. So this one would be doing the rest of the controls, like the inputs, and maybe like the LEDs is driving and all that stuff, and probably controlling some of the other functions like the outputs. So you can see how all these contacts on here are basically just fingers on the board. and that's how it connects to all those external connectors. And the switching power supply is pretty simple. It's not too complicated. These here you'd have to be like careful, not to touch them because they could still be holding a charge. So don't be holding boards like this that have switching power supplies down by these pins, because you could get a nasty zap there. And I think this one has a bleeder resistor. Yeah, these right here would be the bleeder resistors, looks like. So those capacitors should not have a charge, but I mean, you still want to be careful. You can kind of see that this resistor here would get pretty toasty because the board around it is like all discolored, as well as this other transistor down here. Yeah, this is a BC 337, so that might be being used as like a voltage regulator, I would guess, judging by this 5-volt line that's like right here. Cool thing about this board is that they have like everything printed here on the board of what it goes to, like what each pin does. So if you were like troubleshooting one of these things, it would be like pretty easy to, to like figure it out. You don't have to be sitting there trying to figure out what every single pin does or how it's wired or anything. Gonna switch gears a little bit here now, and we are going to do a little experiment. And as it turns out, I was actually wrong about this thing. This is not a vacuum pump. This is actually just a small, basically air compressor. And what it does... Right, so I seem to be having some sort of microphone connections issues, and I'm going to have to re-record this portion again because I was rambling and then I found out that there was no audio. But to recap what I had said, is that this next portion is a little bit dangerous because we are going to be having mains running through the system here. And not everything here works on mains. All the valves and stuff all work on 24 volts, except for the motor, which works at 40. So with that said, don't try this at home. Not only because it's dangerous that there is mains present around here, but also because people that you live with, their spouse or whatever, may not be too happy with you having a deconstructed dishwasher, just kind of sitting there. Just let me do the demo here, all right? This portion here is the only one that has AC from the mains, and that would include the connector here for the heater, which is why I left this unplugged. The sensor here, I just left that plugged in just so that it doesn't throw like a code or anything about, something wrong with the sensor. So as I was saying earlier, this totally did not work the way that I thought it did. It's not a vacuum pump. It's actually more like a little compressor. So what it does is it pumps air into this gasket tube, and basically it starts filling it up, and its girth, like increases, it gets fatter. So that's what seals the upper lip of the tub against the bottom of the top side of the cabinet. And so yeah, I was completely wrong about the whole vacuum thing, which honestly did not really make any sense to me, but for some reason I thought that's maybe what it was. So yeah, it's really not. And something that people that are familiar with dishwashers may have noticed around here is that there is no fill switch. So, or like a level switch or whatever. So this thing does not actually measure the level of the water inside the machine when it's filling up. What I think it does is I think it actually uses the motor to detect that. And we're going to see how that actually works here in a little bit once we actually power it all up. So without further ado, let's go ahead and connect this to power. Okay, I let the wires just kind of dangle down there on the other side of the bench. And we're going to have to go ahead and connect this to power. And we're going to hear some stuff out of here from the controller board. Just kind of makes a little tone there, and it's powered now. We can see that if we hit the power button on the display here, or on the little control panel, that comes on. It says 99 minutes, and touching these little capacitive sensors here will change the modes and stuff. So okay, so it appears that these capacitive buttons right now are disabled because I have the drawer closed. So if I open the drawer, okay, now it's open. Now let's see if it allows me to touch these capacitive buttons. Yep, now it lets me make changes. You can see there, I think that's the one that does the the eco mode or the power saver mode or whatever. And this one right here would change the the wash type. So I don't know what it's set to right now, but let's go ahead and start a wash cycle. Well, right now, since the drawer is open, it shouldn't let me. And yeah, so that's not working. So let's go ahead and close the drawer. Now the drawer is closed, and we can start the wash cycle. And we can see that the motor here is rotating, and the pump is pumping. And we'll see this tubing here just kind of enlarge, and you can kind of see it moving there. So yeah, this is getting filled with air, and it's getting pumped up. If we activate the flood switch, so this is the flood switch now, I'm going to act like there is too much water down at the bottom of the washer. So I'm going to push this. It doesn't do anything right away, but after a few seconds it's going to show an error here. Okay, I've been holding this down for a bit here and it's not doing anything. So I'm wondering if it only detects the flood switch before you actually start the machine working. So I'm just going to let it go for now. The LED for the rinse aid dispenser is just this little red thing right here. So that's the color you would expect to see on the other side of the rinse aid cap. And so this is the motor spinning. See, what I think it's doing there is I think that's where it's trying to sense the level of the water inside the machine. So I guess what it would do is if it detects like a increase in current or whatever from the motor, then it knows that it's got the right amount of water inside the tub. Because as I mentioned, there's like no other switches or anything that would indicate water level, and I mean obviously this thing would not fill up completely with water. So it'll continue doing this for a while. Eventually it's going to give us an error on the display here, because I think that's where it's detecting that it doesn't, you know, have enough water or whatever. And down there in the bottom there's a little smiley face. And at this point we would expect the tub to be sealed up against the top of the cabinet. This fan is not going to do anything at the moment because this one's only used for drying, I believe. And I think it might actually also be triggered by detecting the heat from the power supply unit. Because as it turns out, there's this small diode looking thing down there underneath the heatsink, which I believe is also a temperature sensor like the one that was on the heating element. So there we go. It finally got to the point where I guess it's detecting that things aren't working properly. So it gives that U1 error code. I haven't looked it up. I have no idea what it actually means. But okay, let's just go ahead and stop this so it stops beeping. Okay. The drawer switch here appears that it's doing a double duty. Not only is it used to detect whether or not the drawer is closed, but it's also used to complete the circuit coming from the main board to the valve. So as long as this thing is currently in like a wash mode and it's in the middle of a wash cycle, then this valve is allowed to operate, because otherwise if this valve is not powered, it's basically open the whole time, so air can kind of go in and out. So when you set the machine to do a wash cycle, it energizes this solenoid and closes the valve. So if you open this switch, it opens the circuit here and opens up this valve to let the air out of the tubing, as we'll see right now. I'm gonna basically act like I'm opening the drawer while it's in the middle of a wash cycle, and there we go. All air is released, and now this thing's complaining that something's up. Now it says U2. Not the kind of music I would expect to hear from U2, but okay. The only way I seem to be able to get the flood switch here to do anything is to activate it while we're turning on the machine. So there it'd be on, and I'm still holding the switch down, and there you go. It says F1. And the motor starts pumping the way it would if it were like trying to drain the water out of the machine. I mean, the motor can't really pump the water out of the very bottom of the cabinet because there's really nothing down there to pump the water out. But I guess it just tries to pump out whatever water would still be remaining in the tub or whatever, in case that's what's leaking. We're going to take a look inside of this little air pump now. But one thing that I noticed about all the solenoids on all the assemblies inside of this washer is that they all come apart. So like if I pull this tube out of here from the relief valve, you can actually just pull the solenoid right off of the valve like that, and inside of here it looks like there is a little rubberized plunger. So what would happen is when this coil is energized, it'll pull that plunger and seal the hole that would be like on the opposite side of this little tube right there, and that would keep the air from escaping. But you can kind of see how that little plunger just kind of moves in there when I tilt it back and forth. So that's how that valve works. The pump itself, the solenoid also can just come right off. And let's just remove this plastic bracket off of this little rubber shock mount, and that'll allow the solenoid to come off, or the coil. So basically what's happening is that one of the microcontrollers is controlling the solenoid and turning it on and off really fast. So that would make the plunger in here, you know, like kind of go back and forth really fast, and that's what would do the pumping action. Because otherwise, if this were just to be energized with DC and have it, you know, be powered up just constantly, this plunger would just, like, you know, pull down or pull up or whichever way it goes, and it would do nothing. Now let's go ahead and open this up. Okay, so all 3 screws here are loose now. And this is the pump body, and oh, that just comes off real easy. Okay, so there's the plunger, and it looks like a tiny toilet bowl plunger. So this would be going back and forth like this and pumping the air. This right here is going to be probably a couple valves then. Okay, that came out. So looks like little reed valves, little flappers there. So these would allow the air to come in through this little port right here, which is the one that we saw on the other side. So when the plunger retracts, when it gets pulled by the solenoid, it would retract, pull air in through here. One of the flapper valves would seal up against that hole so that it can't pull air from the outlet. And so this cavity here, like that, it would fill with air, and then once it retracts and it goes back to closed, then it would expel the air out of the outlet port right there, and, you know, continuously fill up that tube that seals up against the tub. So this would be just constantly going back and forth like that, pumping the air. So I'm wondering if there's a spring in here. Yes, there is a spring in here, and this spring would be the one that pushes the plunger back, and it's actually got a bit of force on this spring, so it pushes back a little hard, but it has to be able to pump the air into the tube. So that's basically how that works. It retracts the coil, pulls the plunger in, the spring returns it. So yep, fairly simple little pump, but it requires the solenoid to be constantly pulsed in order to be able to pull the plunger back, and then the spring returns it, pull the plunger back, returns it. Just real quick, I've got a 24 volt supply connected right here, and we'll see how when I apply power to the coil, how this is going to pull the plunger in. So let me get this lined up right here, and I'll try not to block the view. Woo! It shot out because I didn't keep contact on it long enough, so the spring kind of shot it out. But let's try it again. There we go. So we saw how that just kind of pulls all the way in, and then if I release it, it shoots it out. Actually, it turns out this solenoid is not a 24 volt solenoid. This one's a 12 volt, and it's printed right here in the back. I was wondering why this one was a different color compared to the rest of them on this washer, because the rest of them are 24 volts. So that's why the power supply has a 12 volt rail as well as the 24 volt. A couple more little quick tidbits before we close off this video. But one thing I noticed when I removed these rings that lock down the rotor to the rest of the motor body is that not only are they a different color and kind of a different shape here, but when I pulled them off, the rotors themselves, the impellers for the pump for the outlet, they're slightly different. Well, I mean, they're quite different actually. This one here has these sort of like wedge-shaped blades, and this one has these sort of like rubbery paddle type blades. And I don't know if this was the upper drawer and this was the lower drawer, so I don't know if there's a difference there, you know, for how high the water has to rise, you know, to pump out or whatever. Or I don't know if like these were replaced at some point and this just happened to be like a different design, you know, than this one. I mean, I don't know which one would have been replaced or anything like that. So yeah, just a little interesting thing there, and don't really know why. It's just that's how it was. And one other thing here about the control panel is that this is what it looks like when it's, you know, in its sort of a little case, and this is what it looks like outside of the case. I was actually expecting to see like a microcontroller or something for the display itself, because the interface here uses like a clock signal. It's got the data, it's got a what I think is a strobe or store, I'm not sure exactly what it means. It just says like STR on the board, as well as, you know, 5 volts ground. A line for the buttons is I think is going to be like an analog line, so that each button like sends a different voltage back through that line, kind of like using a voltage divider. It also has a 24 volt line, but I think the 24 volt line is for the backlight LEDs, which you can see down there underneath the LCD itself. So they're behind this sort of like diffuser plastic, and I think it's just because they're probably all in series. So it feeds 24 volt to the positive of all those, and then I'm guessing it probably uses a couple of transistors to switch the ground line, so that the display can either be green or red, you know, depending if it's functioning properly or if there's an error. But as I was saying about me expecting to see a microcontroller for the LCD, there actually isn't. All 3 of these chips that are on here are 4094, and those are shift registers, which means that this would be like real easy to reverse engineer. I don't really know what I'd put it to use for. I'm just saying that, you know, it's really easy to figure this one out because of the fact that it's not really using any custom parts or anything programmed. It's just a bunch of shift registers. I think about the last thing we can look at is the rinse aid and the detergent dispenser. And this valve over here is the rinse aid pump. So it's not actually a valve, it's a pump, and you can see it says 24 volts DC there. We can get at the right angle and at the right focus. And on the other side we have the 24 volt DC diverter valve. So these 2 solenoids actually will just pop off if you like take a flathead or whatever and like pry these off, as I've already done over here. But except this one, I cut this back cover off so that we could see how exactly it sort of works in there, or how the water flows. And when we take these off, these solenoids, it turns out that this little pump right here, what it is this thing right here. So it's like another little plunger, and it's got a spring, a little return spring, but there's not a whole lot of motion on this plunger. As you can see, it's like very tiny amount of like excursion on that. So this yellow part that's inside here, that's where that's actually kind of like the valve body. So it's got these small valves that just kind of, one fits in here. Whoops, and I just dropped it. But anyway, the other one's inside. So this thing just kind of goes back and forth, and it pumps the rinse aid, I guess, from the reservoir in here, and it pumps it out. So I believe there's a hole down there, so I believe that's where the rinse aid comes out. Oh yeah, you can actually see if you look in there, it's kind of hard to see, but the end of that valve actually protrudes. So this valve right here actually protrudes from in there. So that's where the rinse aid comes out. And then for this diverter valve, what it is the water comes in through here, and there's actually a channel that it follows that goes to that little body there. So if we open this up right there, water goes in to that little barb. It flows up this way into this channel right here, and it comes down and it goes inside here. But I mean, that's in there. So if we take off the diverter valve, what we find inside is this other sort of plunger that the solenoid can pull down on, just like that. And so the water appears to come in through the center, and when this valve, or when the solenoid is not activated, this plunger kind of sits up there, and it blocks water from being able to flow up into this area, which would come over this way, up this wall, over across, and into that hole right there, which on the dispenser appears to be the rinse cup right there for like the small amount of detergent for like rinsing everything off. This here is, I believe, like the main wash. So when this is blocked and water's not flowing up this way, it's able to flow out through the side. There's an opening right there which leads over to this channel. So water is able to flow up through this channel all the way up and around and through that hole, which makes it so that all the water lands on the main wash cup there. So when this sits in there like that, when it's not activated, the water comes in and it just flows out through here. But when the solenoid activates and this closes, water comes in through here but can't go back out this way, so it just goes up through the other hole. So very simple, but I believe that's how that's actually working. And one other small thing here, I was a little bit wrong about the way the LED works in this thing. So this actually got cut off because I used like one of those oscillating blades to kind of like cut all the way around. So I ended up cutting this off, but this fits in there something like this. All right, so it's something like that, if I could actually hold it. So when this floater is floating, the LED is always on, but this floater blocks light from being able to be seen through that window on the rinse aid cap there. But when the rinse aid starts dropping or gets empty, then this thing folds down, and now the light from the LED is able to be seen on the rinse aid cap. So I believe that's how that's working. I mean, it kind of makes sense to me. So yeah. All right, so I think that's pretty much going to do it for this one. I think we've explored everything that there is to explore in this washer, or at least like the more interesting stuff. So thanks guys for watching once again. We're going to end the video here, and I'll see you guys around the bench.